Hello, we are Group 3, and today we will be talking about road ratings in the city of Syracuse. So, our objectives for Part A will break down our sample population to examine the different variables descriptively, analyzing them each individually, and then later on we will analyze their effects on the dependent variable. So, all the different variable types we have in our data. Street ID is a unique identification number for each street in the data set. The block is the block number of the street in question. The name is the name of the street in question. The type, the avenue, boulevard, etc. The direction in which traffic flows on said street. Crack rating on a scale of 1 to 5 rates the crack repair job on the road in question, 5 being the best, 1 being the worst. Patch, same deal. Rating of the patch repair job on each road, 5 being the best, 1 being the worst. Length of the road, width of the road. Months since last rating of the road in question, broken down by month and year. Overlay is the years since the last repaving of the road in question. FO dummy, there's 2 techniques to paving a road using flush or oil. We set flush roads equal to 1 and oil roads equal to 0. And we have an interaction variable between said dummy and the years since last overlay, analyzing how each technique interacts with overall rating and the years since last overlay. Class of the road, local, county, minor arterial, and principal arterial, analyzes how busy a road is. And then the overall rating, which is our dependent variable. We got this data from data.syrgov.net, which is the official website for the Syracuse local government, which they released this data on their roads. We imagine this stuff originated in their highway department or some similar entity. Right, so the population of interest is all Syracuse roads, but then we cherry-picked 974 of the roads in question. These were the ones that had the most complete data. We believe that our sample is still representative, if not exactly random, since roads are likely to be in similar condition if they're in the same geographic area of Syracuse. So, the breakdown of each variable. Start with the overall road rating. Scale of 1 to 10, the mean overall rating is 6.32, the median rating is 6, and the standard deviation is 1.74. A year since last overlay. This variable describes the last time the road in question was paved. If we did not have a value for this variable, we set it to 36, which is 1 year longer than the longest year listed in our data set. And this time series shows overall rating based off of years since last overlay. We do have a strange spike around 32, which we considered an outlier, and as you can see, 36 starts to curtail up, and that we believe is due to our own changes to the data. Months since last rating, it's just a time series of months since last rating versus average rating overall. Seems rather random, doesn't seem to be much of a pattern here. Flush versus oil. There's far more flush roads than oil roads in our data set, and the flush roads have an average overall rating that's a little bit higher at 6.37 compared to oil roads at 5.73. And then our interaction variable, which is that flush versus oil dummy times years since last overlay, shows that every additional year since last overlay has a different effect on overall rating depending on the method used to pave the road in the first place. Patch ratings. Scale 1 to 5, 5 indicates the best quality. 3 was the most common rating, with 4 and 5 not too terribly far behind, 2 just barely edged out, and then 1 a distant 5th. Crack rating. This one is a little more pronounced. 3 is the clear winner here. 4, 5, 2 far below, and then ratings of 1 nearly non-existent. So they're doing a good job of crack repair, or at least not a horrendous job. Length and width. The average length of roads from our data set was 575.26 feet. The average width was 39.35. Class of the road. There were many local and minor arterial roads in our data set, and not too many principal arterial or county roads. Street direction. Most of the roads in our data set flowed south and east, west not too far third, and I guess most people don't need to go north in the city. So, descriptive summary. There's a downward trend in overall rating in relation to years since last overlay, except when we get to 32 years ago, which we think is an outlier. The common Syracuse road has a crack and patch rating of 3, was paved with the flush technique, and is a local class road. Syracusans seem to drive south and east, as these are the most common road directions. Our data set contains many qualitative variables and ordinal quantitative variables, and this data set could be improved if some of those could be represented in continuous quantitative measures. For example, if we had like an actual surefire way of measuring the quality of a patch job on a road instead of a vague rating that's subject to human interpretation.
So for part B, we will examine the independent variables to determine which are included as the predict of dependent variable. We will then evaluate our model. So our dependent variable is overall rating, and we have 8 explanatory variables. We will just examine the correlation between the explanatory variables and our dependent variables. So let's talk about our expectation. The first one is crack. We expect the more the crack, the higher the overall rating, because more crack repairs means higher quality of the road. And for the patch, we expect higher the number of patch, the higher the overall rating, because it means the road is carefully maintained. And for the length, the longer the road, the higher the overall rating, because better quality pavement is for longer roads. And for the width, wider road, the higher the overall rating, same logic with the length variable. And for our month since last rating, we do not expect this variable to have any impact on the overall quality of the road. And for the year's last overlay, we expect the quality of the road to decrease the longer it has been since the last overlay, indicating a negative relationship. And for our flush or oil dummy, we expect the rating of the road to increase when the dummy equals to 1. That means the road is flush. And last one is the class number. We expect the quality of the road to increase on the more major road classes, since they are more likely to be well maintained when compared to less roads.
So we have explained our expectation, and now we will explain what the real data tells us. First, the crack. Based on our data, it has a really strong correlation, and it matched our expectation, which is positive 0.851. Next is the patch, which is also match our expectation, and it has also strong correlation of 0.77. And next one is length. It has relatively no correlations, no relationship, but it doesn't match our expectation. And the width, it has weak correlations of around 0.206, and it matched our expectation. In the month since last rated, it has a relatively weak correlations of negative 0.158, and it doesn't match our expectation. That we didn't expect any correlations between these two. And the year since last overlay, it matched our expectation that it has a relatively strong correlations around 0.671, and which means the longer the time since last overlay, the lower the ratings. Next is the flush or oil, and it matched our expectation that flush road is better than oil. Next is the last one is the class number, and it also matched our expectations that the higher the road class number, which is the PA, is better than MA and better than county and better than local. And next will be the and our correlation summary was the highest correlations is crack, patch, and year since last overlay, and the lowest one was length and month since last rated.
So to build our model, we built a multiple regression with all of the variables we described earlier, but we wanted to take that one step further, so we did a backwards elimination to end with just 6. You can see some of these don't have the best p-value or the most significant coefficient. We kept those in because they were requirements to the project, and to end with equations that we could use. So those are broken down with the dummy variable into if the road is oil or flush, two different equations, as you can see with two different intercepts and then the different interaction on the overlay. So we'll break that down further into the coefficients of each. We had two positive relationships with the crack. If 1 point increase in crack, there'll be an overall increase in 1.148. That was the biggest coefficient we had. And that also held true with patch, which 1 point increase in patch increased the overall rating by 0.59. We had two negative relationships. This was with everything else held constant. 1 more month since the last rating will decrease the overall rating by 0.004. Then with everything held constant for the year since last overlay, again, we have two beta weights for that one because it was our interaction with oil and flush. So for oil, it's almost no change with 0.001 and flush decreasing by 0.023 on the overall rating. And then finally, for our intercepts, when everything is equal to 0, flush-treated roads are rated 0.602 higher than oil-rated roads. And the final breakdown of that was to look at our p-values. Obviously, we really liked the crack and patch variables because those had the biggest effect on our overall rating. Our year since last overlay looks terrible, but again, we kept it in because of the interaction with the flush and oil, and we do believe that it's that high because of our outlier that we mentioned before. So we wanted to do one final hypothesis test just to make sure that our sample was a good representation of our population. Because we got this from the government website, and actually we were able to get a population mean, which is the mu and a sigma, compared to our sample. So our alternative hypothesis was that our mu is equal to 5.99, and at all significance levels, we rejected the null hypothesis to say we had sufficient evidence that they are in fact equal. So to wrap everything up, we do think that our model is pretty good indicator of the overall ratings. We think it can give companies and governments a way to decide which roads needs treatment the most. We definitely think there's some room for improvement though. If we could, we would want more continuous quantitative data rather than those ratings that we've been going over. And finally, we would want to reevaluate our year since last overlay because intuitively we think it's a really good indicator. So we would look for a better way to improve those NA values that we gave a value of 36. And then we'd also like to remove the outlier that we saw at 32. And so thank you very much for listening to our presentation.